Welcome to this video, in which I will tell you a bit more about the team behind this MOOC and what motivated us to create this course for you. Not only will you get to know our people, but you will also be introduced to our exoskeleton. By the end of this video, you will understand the basic structure and working principles of an exoskeleton. We'll elaborate more on these basics in the next weeks on this course. If you still have questions after watching, don't hesitate to contact us. Now, let's start by taking a closer look at the structure of Project March and who we actually are. So we are a non-profit student team consisting of students that come from various disciplines and faculties. Most of us are students from the Technical University in Delft, the Netherlands. Our study backgrounds range from industrial engineering and clinical technology to electrical engineering. Together, we work on this project for a full year, doing so full-time. We do this on a voluntarily basis, so we don't get paid, but we see this project as a unique opportunity to work on such a cool project and meet new people. It's also pretty amazing that we can contribute to a technology that fascinates us and yet can have such a societal impact. Working as one team towards one goal is what defines Project March. Now, every academic year, a brand new team is recruited, who takes over from August and continues to the next summer. There have been 5 teams so far, and here you can see the 4th, the 3rd, the 2nd, and the very first team. Now, even though we are a student team, there isn't a professor guiding us. We have our own management department, who are also students, and we do our own acquisition, PR, and everything you can find about us online on our website. We design everything ourselves, and although some of the parts of our exoskeleton are produced by companies, we have our own workshop where we build and test our exoskeleton. Now, we built this exoskeleton as a way to push the boundaries of exoskeleton technology. Since we only make one exoskeleton each year, which isn't designed for commercial use, we can try out a lot of new technologies and constantly reinvent our design. Now, this design for our exoskeleton is tailor-made to one specific person, our pilot. The pilot is the person who is in control of the exoskeleton. We use the term pilot as they are controlling the exoskeleton. Our team works together with one pilot each year. These pilots have a spinal cord injury and voluntarily work together with our team. Now, during the year, each team of Project March participates in a competition if the circumstances allow it. Yes, there is actually a competition for exoskeletons. This competition is called the Cybathlon, and it has a discipline called the Powered Exoskeleton Race. It's basically an obstacle run, designed to push the exoskeletons and their pilots to the limit. Every team which competes in the Cybathlon tries to complete the obstacle run as fast as possible. Fast is still a relative term though. An exoskeleton is still a lot slower than walking normally. So now that you know more about us, it's time to take a closer look at our exoskeleton. We are currently working on the 4th prototype of the suit, which you can see here. It's easy to understand how an exoskeleton works if you compare it to a human. For starters, you need a frame, which is kind of like the bones of our body. This is the part of the exoskeleton that supports the weight of the pilot. Here you see the leg bones and core structures as found in our exoskeleton. Now, these bones have a lot of forces working on them, as you can see in this scheme, and the frame is often made from aluminium or carbon. We'll talk more about the frame in the next few weeks, alongside another mechanical component, the joints. The exoskeleton has 8 active joints, 4 on each side. You and I have 100 joints in our body which we can move, but we can't fit that many in the exoskeleton yet. Based on the type of movement the exoskeleton joints can make, they can be classified as either linear or rotary joints. With the addition of new hip joints in the latest March exoskeleton, we can actually step to the side for the first time. To ensure that the pilot stays in place while walking, the exoskeleton has various fixtures that strap the pilot in. One of those is the hip fixture, which kind of resembles a corset. This component is exactly fitted to the pilot's back with the help of a specialist. The other fixtures are the rigid upper leg fixtures and lower leg straps. But with these components, an exoskeleton cannot walk just yet. You need electronics and software to make the exoskeleton move. Our exoskeleton is equipped with a backpack, which holds the battery that is the power supply. The backpack also holds many other electronic components, as is shown here in the picture. These electronics serve two functions: data communication and power distribution. Now, the exact function of the electronics and how the software works is quite complicated. To explain it in a simple way, the control of the exoskeleton is written in the software, and thus the software manages the system as a whole. Now, besides the electronics and software, there are two more basic aspects of our exoskeleton. The first is the input device. Our pilot controls the exoskeleton by using an input device that has been integrated in one of her crutches. In this device, among other things, she can select different gaits. Now, a gait is a pre-programmed movement pattern of how each joint has to move at a certain time. A gait will, for instance, say, first lift the knee joint and then the ankle joint. Now, we'll explain each of these aspects in more detail in the next few weeks. But since you now understand the basics of our exoskeleton, let's see it in action. Try to see in this video if you can spot all the parts which I just talked about.